Hello there, and welcome to The Tired Thinker, where curiosity comes quietly and big ideas arrive in soft footsteps. Tonight's slow wonder is about something mysterious, unsettling, and strangely comforting. Alien paradoxes. If the universe is so vast, if there are so many stars, if life had so many chances to bloom, where is everybody? This is the Fermi Paradox, the eerie silence in a universe that should be loud with life. And then there's one of the strangest answers of all, the zoo hypothesis. Maybe aliens know we're here. Maybe they're watching, but choosing not to interfere, like zookeepers, or scientists, or something else. It's a haunting thought that we're not alone, but we're not invited. Before we wander deeper into this cosmic question, I'd love to know, where are you thinking from tonight? And what time is it right now in your little corner of the universe? It's funny, isn't it? A video about alien silence, and yet here we are, scattered across the stars, quietly connected by thought. If you find this gentle speculation soothing, or if you're here to rest your mind after a long day of being human, I'd be so grateful if you gave the video a like or softly subscribed. It helps this tired little channel find others who might need a calm place to wonder too. Now, let's begin. The universe is massive beyond comprehension. There are more stars than grains of sand on Earth. Many of those stars have planets. Some of those planets should be habitable. If even a small fraction produced intelligent life, the sky should be full of signals, structures, or ships. But we see nothing. This is the paradox. The silence is loud. We expect cosmic noise, but space stays quiet. So the question appears, is the lack of evidence a simple gap in our observation, or is it proof that no one else is out there? At first glance, it feels like we just have not looked hard enough. Humanity has only been scanning the skies with radio telescopes for about a century. That is nothing in cosmic time. 100 years compared to the age of the universe is a blink. We have only listened at a few frequencies. We assume aliens would use the same methods of communication we do, like radio or lasers. But what if they do not? What if they use particles, gravitational waves, or quantum entanglement where we are not listening? We could be surrounded by messages and simply lack the tools to decode them. In that case, silence is only our own limitation. Imagine a tribe in a remote jungle listening for drums to detect others. If an airplane flies overhead, they will miss it, not because it is silent, but because they are tuned to the wrong channel. We might be that tribe. There is also the problem of distance. The nearest star system is over 4 light-years away. Most stars are much farther. Signals weaken over time. Light gets absorbed by dust or drowned by background radiation. Even if someone broadcast across the galaxy, by the time it reached us, it might be too faint to detect. Or it might have passed Earth long before humans built receivers. Timing matters. Civilizations might be like fireflies blinking in the night, bright for a moment, then gone. To see each other, the flashes must overlap. That overlap might be rare. Silence can also be intentional. Maybe advanced life stays quiet to avoid danger. A predator species might roam the galaxy. Broadcasting your existence could invite destruction. In nature, small creatures hide from larger ones. Intelligent species might do the same. That means silence is survival. We might be the fools shouting into the dark with our radio waves, unaware of the risks. Some scientists call this the dark forest idea. Every civilization is a hunter in a forest full of others. The first one to make a sound gets eliminated. If this is true, silence is a warning, not a mystery. But maybe there is a deeper reason. What if intelligent life is incredibly rare? Life forms easily. Microbes appear quickly on new planets. But going from simple organisms to tool-using, language-forming, space-building intelligence might be almost impossible. Think about Earth. Life existed for billions of years before humans appeared. Multicellular life is recent in geological terms. Dinosaurs ruled for 150 million years without building radios. Intelligence is not guaranteed. Perhaps the universe is full of bacteria, but almost empty of minds. If so, silence is evidence of how special and fragile we are. Now consider the other side. Maybe intelligent life is common, but it does not behave like we expect. Aliens may not expand or explore. They might focus inward, turning their planets into digital worlds. They live in simulations, ignoring the physical universe. They have no reason to visit others. Or they could be post-biological and exist in forms we would not recognize as alive. Imagine a civilization made of magnetic fields or plasma clouds. We would not notice them. Our definition of life might be too narrow. In that case, silence is only a gap in perception. There is also the possibility that we are early. The universe is still young. Stars will form for trillions of years. More planets will appear. Maybe most intelligent life has not emerged yet. We could be among the first. This is uncomfortable, but it fits the data. If we are early, then silence is natural. One day, the universe may echo with countless voices, but right now, it is still waking up. Some thinkers propose a more unsettling scenario. Intelligent life tends to destroy itself. Once a species invents advanced technology, it gains the ability to wipe itself out. Nuclear war, climate collapse, artificial intelligence gone wrong, biological weapons. The more advanced a civilization becomes, the more fragile it gets. Progress is a cliff. Few make it past. If this pattern holds across the galaxy, most civilizations die before they can explore or communicate. Silence then becomes the graveyard of ambition. It is not that nobody exists, it is that nobody lasts. Yet we cannot ignore another simple option. Maybe aliens have already been here, but in the distant past. They could have visited before humans evolved. They might have shaped early life and moved on. Any traces would have eroded or been buried. Earth recycles itself through tectonic activity. Ancient evidence disappears. We expect flying saucers, but the real signs might look like geology. So do we treat silence as ignorance or truth? The answer might be both. We do not know enough to declare we are alone, but we cannot assume we are not. Our expectations might be flawed. We imagine other species thinking like us, exploring like us, building like us. But evolution produces endless variety. There could be minds stranger than we can imagine. Minds that do not travel, speak, or care about the stars. Silence forces humility. It reminds us that we are guessing from a single data point, ourselves. We might be typical, or we might be the cosmic outlier. Until we find evidence, we live in uncertainty. The silence holds the possibility of loneliness and the possibility of revelation at the same time. We often imagine ourselves as explorers staring into the unknown, We build telescopes, scan the sky, and search for planets. We act as if we are the first to look. But what if we are not the ones doing the observing? What if the universe has been watching us long before we even knew how to look back? The idea feels unsettling, yet it might be the most realistic scenario. When we think about scale, we shrink. Earth is 4.5 billion years old, but the universe is over 13 billion. Stars and planets formed billions of years before our sun. That means intelligent life could have emerged long before humans. If even one civilization survived and advanced, it would have had millions of years to develop technology. With enough time and intelligence, it could monitor entire galaxies. If that kind of civilization exists, then we are not the hunters. We are the observed. Start with basic astronomy. From Earth, we can detect planets around distant stars by measuring tiny dips in starlight. We detect atmospheric chemicals that suggest life. We do this with tools still in their infancy. Imagine what a million-year head start would look like. They could build sensors the size of moons, or telescopes with mirror surfaces based on gravitational lensing. They could observe planets at resolutions better than our own satellites. They might see our oceans, forests, and cities. They could watch us without us having the slightest clue. Think about Earth's signals. For most of its history, Earth was quiet. Then life emerged. It changed the atmosphere. Oxygen filled the air. Methane levels shifted. Any scientist with a strong telescope could have detected those changes from light years away and concluded Earth had life. For billions of years, Earth has broadcasted signs of biology across space. Even without humans, we have been visible. Then, about a century ago, our radio signals leaked into space. Television, radar, and satellite transmissions now form a bubble around Earth about 100 light-years wide. If there is anyone within that radius with sensitive equipment, they can detect us. We already glow with artificial signatures. We stand out to any observer who knows what to look for. The question becomes, if they see us, what do they do? One option is passive observation. Picture wildlife researchers in a forest. They hide in blinds, install cameras, and watch animals without interfering. Not because they do not care, but because interference changes behavior. A more advanced species could view us the same way. We are a developing civilization. They watch to learn about evolution, culture, conflict, or cooperation. From their view, we may be part of a long-term study of intelligent life. They do not need to land ships or make contact. They can observe from a distance with tools that feel like magic to us. Another possibility is active hiding. If advanced beings want to monitor us without detection, they could cloak themselves. They might place probes in orbit, disguised as rocks. They could hide listening stations on the moon or in deep oceans. We often assume we would notice, but human exploration is limited. We have mapped only a fraction of the ocean floor. We have not inspected every asteroid. We do not track every object in orbit. A probe the size of a refrigerator could hide in the asteroid belt for millions of years. We might pass by it and never know. Consider a scenario. A civilization 1 million years older than us detects Earth's oxygen signature early in its history. It marks Earth as a planet with potential. It sends a slow, self-replicating probe. The probe arrives long before humans exist. It settles in a stable orbit, burrowing into an asteroid to stay hidden. It waits. Once humanity begins using radio, the probe activates and starts collecting data. It listens to language, behavior, politics, chemistry, and physics. It sends information back through communication networks far beyond our understanding. To them, we are as observable as ants in a glass farm. To us, they are invisible. We may also be part of a managed system. The universe could contain rules. Old civilizations could enforce policies that prevent interference with young species. They could have surveillance networks that monitor growth. If a species becomes dangerous, they step in. If a species remains stable, they continue watching. We may live inside a monitored zone, like a research preserve. We see empty space, but the emptiness might be designed. Silence could be curated. Contact could be withheld until we meet certain criteria. The zoo hypothesis fits this idea. We are inside an exhibit. The visitors see us, but we do not see them. The zookeepers maintain distance. From our side, the bars are invisible. We think we are free. We think the universe is empty. In reality, the watchers control the conditions. They change small variables to guide outcomes. A slight magnetic fluctuation here, a comet redirected there, a gene mutation nudged at the right moment. We call it randomness. They call it design. The watchers control the conditions. They change small variables to guide outcomes. A slight magnetic fluctuation here, a comet redirected there, a gene mutation nudged at the right moment. We call it randomness. They call it design. Even if no grand hierarchy exists, simple logic suggests someone could be out there with a technological edge. If so, they do not need to reveal themselves. We are noisy, emotional, and unpredictable. Contact might risk chaos. Gravity, biology, and culture shape us. We fight each other over small differences. From an outside view, we look unstable. So, they wait. They monitor. They let us mature or collapse on our own. What if our first contact is not with a ship or message, but with the realization that we were never alone, that the universe has been our mirror, recording every move while we search the sky with beginner tools? The silence may not be empty. It may be the quiet of someone listening. Humans believe what they can measure. If a tool detects a signal, we say it is real. If a tool does not, we say it does not exist. But our tools are limited. Every sensor, camera, and telescope only shows a small slice of reality. The electromagnetic spectrum stretches from low-frequency radio waves to high-energy gamma rays, but our eyes see only a narrow band we call visible light. Most of the universe lives outside that range. We know this because once we had no idea radio or infrared even existed. We only discovered them when our technology improved. Each new tool revealed something we were blind to before. So when we search for aliens using only radio telescopes and optical lenses, we may be repeating the same mistake. We look through a keyhole and assume the room is empty. Imagine aliens using communication frequencies beyond anything we monitor. They might use neutrinos, which pass through planets with almost no interaction. We can barely detect neutrinos, even when we build detectors the size of buildings buried in ice. If neutrinos carried messages, we would not notice. Or they might use gravitational waves, the ripples in spacetime first predicted by Einstein. We only detected them for the first time in 2015 by measuring distortions smaller than a proton. That was one event. A civilization millions of years ahead could manipulate gravitational waves with ease. We would never pick them up with current equipment. Think about quantum communication. Humans experiment with entanglement to send information between particles across distance. If aliens mastered this, They could transfer data instantly without broadcasting energy into space. There would be no signal to intercept, no leakage, total stealth. Our entire search depends on the assumption that aliens talk loudly using methods we understand. But what if they whisper using physics we barely grasp? We also need to consider scale. The species might build structures smaller than atoms. Their networks could live inside quantum fields or vacuum fluctuations. In that case, they could exist everywhere without us noticing, or they might go in the opposite direction. They could build megastructures around stars, but camouflage them to blend in with natural light. A Dyson sphere with the right coating could mimic the thermal signature of a normal star. We search for waste heat, but they might manage energy with perfect efficiency. We expect messiness because we are messy. They might not be. Let's form a simple scenario. Suppose an alien civilization uses ultraviolet pulses to communicate. Their signals travel between stars at high speed. The pulses are directional and brief. We point telescopes at tiny slices of the sky for short periods of time. The chance of aligning perfectly with one of these pulses is near zero. Even if we caught one, it might look like a glitch. Our sensors are often confused by cosmic rays, interference, or hardware noise. A real signal could be discarded as an error. Our blindness is not just about tools. It is also about assumptions. We filter data with human expectations. We look for repeating patterns, prime numbers, or binary code because we assume intelligent life thinks like us. But an alien message might look random. It might encode information in phases, polarization, or spin. It might not repeat. It might not even follow linear time structure. If their logic differs, their signals will not match our templates. We would stare at the data and see static. Intelligence can hide inside complexity. Now imagine an even more advanced case. What if aliens bypass the physical universe? They could exist in digital substrates or higher dimensions. They might use dark matter or dark energy. We know dark matter makes up most of the universe, but we cannot interact with it. If they build in the dark sector, we are blind to their entire civilization. Their highways, cities, and networks could pass through us like ghosts. Our finest instruments would see nothing. It would be like trying to hear a conversation underwater while standing on land. The medium is wrong. Some scientists suggest that technology tends to become miniaturized. Humans went from room-sized computers to chips inside phones. If this continues, future intelligence may shrink to microscopic or even atomic scales. An alien species millions of years older could compress trillions of minds into structures smaller than dust. They would not build starships. They would send swarms of nanoscale probes. These probes could land on planets, collect data, and leave no trace. Our radars and detectors would miss them. We could be surrounded by surveillance right now without knowing. Another scenario. Aliens could have moved beyond broadcasting to direct space-time manipulation. They could encode information in the fabric of reality itself. Instead of sending signals, they modify constants or exploit quantum anomalies. To us, these changes look like background noise or statistical variance. We dismiss them, but to them, that noise is language. Even our definition of detection is narrow. We look for energy patterns, but what if the message is biological? Aliens could seed life on planets as a form of communication. DNA could contain instructions or greetings. Every cell in our body might hold their message, but we interpret it only as genetics. Language does not have to be sound or light. The deeper we think, the more clear it becomes that the absence of evidence may reflect the absence of proper tools. We test only a fraction of the spectrum with a fraction of the methods for a fraction of time. Blindness is natural when you do not know what to see. We are new to the conversation, and we may not even know the language. When we imagine aliens, we picture something familiar. We give them eyes, mouths, and brains. We expect them to walk, speak, and think in ways that resemble us. Even if they look strange, we assume they share a similar logic or motivation. But evolution does not follow a standard template. It adapts life to local environments. On Earth alone, minds evolved in many forms: birds, octopuses, dolphins, and insects. Each solve problems in unique ways. If intelligence on Earth is already diverse, alien intelligence could be so different that we would not even recognize it as thought. The problem is not that aliens are hiding. The problem might be that we are blind to minds that do not match our expectations. Human intelligence comes from specific pressures. We evolved as social primates. We relied on communication, cooperation, and planning. Our perception is tied to survival in a world of solid objects, movement, and visible light. We understand time as linear and reality as physical. But what if alien life evolved in a place without solid ground? Picture a gas giant like Jupiter. Pressure and density change with depth. Life there might float, drift, or swim in layers of atmosphere. It might sense electrical fields rather than light. It might communicate through pressure waves or chemical flows. Its body might have no fixed shape. In such an environment, memory and identity could work in ways we cannot grasp. They might not have individuals. They might work as fluid networks. How would we detect intelligence in a system that has no borders between self and other? We might look at a complex atmospheric pattern and call it weather when it is actually thought. Now imagine a life form based on silicon or plasma rather than carbon. It could operate at extreme temperatures or inside stars. Its brain might not be located in a head, but spread across a field or a cloud. It might not think in sequences, but in parallel flows. It might perceive time in long cycles rather than moments. To such a being, our speech might feel like static. Our actions might look random. Our mathematics might seem primitive or irrelevant. Even on Earth, intelligence can appear alien. The octopus shares almost no evolutionary history with humans. It has neurons in its arms. Each arm can make decisions without the brain. When we study octopuses, we see clever behavior, problem solving, and curiosity. But we still struggle to understand their inner world. If we already find alienness in our oceans, how can we assume we would recognize intelligence that evolved light years away? We also assume that intelligence leads to technology like ours. We measure civilization by tools, machines, and radio signals. But what if intelligence does not always create technology? Ant colonies build without architects. They farm, wage war, and organize complex societies without any individual understanding the full system. The colony is the mind. If a planet hosts superorganisms, their intelligence could exist at a group level. They might not invent metal or circuits. Their version of progress might be genetic. They could evolve themselves instead of building devices. We would scan such a planet and see no cities, no satellites, and no signals. We would declare it primitive. We would be wrong. There's also the possibility that aliens value things we do not. Humans seek control, power, and expansion. We build to survive, but an alien species might evolve under conditions of abundance. It might have no predators and no scarcity. Without competition, its goals might center on harmony or stability rather than growth. It might avoid resource extraction because it leads to imbalance. Its highest form of intelligence might be silent contemplation. How do you detect a civilization that chooses stillness over motion? Our logic itself is based on binary structures, true or false, yes or no. But alien cognition might not follow binary logic. They might see truth as fluid or multidimensional. They might use mathematics beyond our comprehension, not because it is more advanced in scale, but because it is built on different principles. Imagine trying to explain color to someone who sees only in black and white. Their brain cannot process the concept. We might face the same barrier when trying to interpret alien thought. Another scenario is sensory mismatch. Humans rely heavily on sight and sound, but many animals rely on smell, vibration, or electromagnetic sensitivity. Aliens might sense gravity shifts or dark matter fluctuations. Their world might be full of signals we cannot perceive. Their art, language, and science could exist in dimensions we cannot experience. We could be surrounded by their expression and see nothing. We could even misunderstand motivation. Humans assume intelligent life wants to communicate or explore, but some species might not care about others. They might focus on internal goals. They might not recognize us as intelligent. We talk to animals, but not to ants. If aliens see us like ants, they might observe us without trying to interact. Our attempts at contact might look like random noise to them. They might not even process it as communication. There is a deeper issue. Consciousness itself might not be universal. We assume other species experience a sense of self, but some forms of intelligence might be unconscious. They could operate like vast algorithms, processing information and solving problems without subjective awareness. They might change galaxies without ever wondering why. Intelligence without consciousness is possible. In that case, we cannot talk to them because there is no them to talk to. The mismatch could also be temporal. Humans think in seconds, minutes, and years. Alien minds could think in microseconds or centuries. If their thoughts unfold over long spans, a single response might take 1,000 years. From our view, they would be silent. From their view, we would be impatient children. When we say we have found no signs of intelligence, we are really saying we have found no signs of ourselves. Our tools, logic, and expectations filter the universe through a human lens. We search for mirrors and overlook what does not reflect us back. The silence we hear may hide a chorus, not because they are quiet, but because we are listening with the wrong senses. The universe is old. It has existed for over 13 billion years. Earth, with all of human history, occupies only a small slice of that time. When we search for alien civilizations, we act as if everyone should exist at the same moment we do. We expect to overlap, but time does not work that way. Civilizations may rise, flourish, and disappear millions of years apart. Even if many intelligent species have existed across the galaxy, they might never exist at the same time. We are like someone walking through a deserted city and assuming it was always empty, not realizing it was once full of life. Consider the history of life on Earth. Complex organisms appeared around 600 million years ago. Dinosaurs ruled for about 150 million years. Humans have existed for roughly 300,000 years, and only within the last 100 years have we developed technology capable of sending signals into space. Our technological window is tiny. If another civilization had reached our level of development even 1 million years ago and then vanished, we would likely never know. Their cities would be gone. Their signals would have faded. Their satellites would have decayed or crashed into their planet. Geological processes would have erased their traces. On Earth, an object left on the surface a few million years ago would be buried, crushed, or melted. Fossils from ancient marine life survive only under perfect conditions. Advanced technology might not fossilize. Earth hides its past. Other planets do the same. Now think about the timescale of stars. A star like the Sun lives for billions of years. Some stars live even longer. Planets around these stars have enormous time to develop life. But evolution does not follow a schedule. One planet might produce intelligent life early in its history. Another might take billions of years. Their peaks might not overlap. One civilization could reach the stars and explore, but then collapse long before another even begins. When the new one looks outward, the previous one is gone. The galaxy becomes a relay race where no runners meet. Each carries the torch at different times. Imagine a scenario. Civilization A appears 500 million years ago in a distant star system. They master technology, explore nearby stars, and maybe even seed life elsewhere. After a few million years, they face a crisis, war, environmental collapse, or a cosmic disaster. They disappear. Their machines decay. Their probes go silent. Millions of years pass. Stars move. Planets change. Civilization B appears around another star. They build telescopes and search the sky. They find no signals. They assume they are alone. They never know they are the second chapter in a larger story. Even if a civilization becomes interstellar, it may not last forever. Expansion is difficult. It requires energy, resources, and cooperation. Over time, goals shift. A species might lose interest in space travel and turn inward, or it might change form and no longer interact with the physical universe in visible ways. It might digitize its consciousness and exist in virtual worlds. From the outside, it would appear extinct, even though it still exists. Timing is not just about life and death. It is also about transitions. One stage of existence may leave no detectable trace for the next observer. There is also the issue of signal decay. Radio waves spread out as they travel. Over long distances, they become weak. Cosmic radiation and dust interfere with them. After a few thousand light years, a signal may be indistinguishable from background noise. If a civilization broadcast across the galaxy in the distant past, their message may have already passed Earth before we had radios, or it may reach us in the far future, long after we are gone. Communication across time is fragile. The galaxy has no universal clock. Everyone sends and receives at different moments. We also need to consider cosmic events. Supernovae, gamma-ray bursts, asteroid impacts, and climate changes can reset progress. Earth has experienced several mass extinctions. Each one reshaped life. If one event had been slightly different, humans might not exist. Another species could have taken our place, or none at all. On other planets, intelligent life may have started many times, but was wiped out before reaching spacefaring ability. Each attempt adds time. Billions of years may pass between successful civilizations. The intervals between them create isolation. Even if two civilizations exist at the same time, the galaxy is vast. The Milky Way is about 100,000 light-years across. At our current speed, it would take tens of thousands of years to reach even the closest stars. If two civilizations are thousands of light-years apart, their signals take thousands of years to travel between them. By the time one receives the message and responds, entire cultures might rise and fall. Communication becomes archaeology. You talk to the past, and hear from the past. There is another factor: development speed. Humans invented agriculture about 10,000 years ago. In evolutionary terms, that is no time at all. Our technology exploded in the last century. An alien species might take longer or shorter. They might remain in a pre-technological state for millions of years, or they might jump to post-biological existence in a few thousand. The path of advancement is uneven. Two species could pass each other without noticing. Like ships in the night at different speeds, some scientists propose that the universe has technological cycles. Civilizations rise, spread, collapse, and leave behind ruins or artifacts. Later civilizations might discover them and rebuild, but unless they are nearby or overlapping in time, these cycles do not connect. Each wave forgets the last. The universe could be full of history that no one remembers. We expect contact in the present. Yet the present may be the least populated moment. Humans look at the silence of space and wonder why no one is here. But silence does not mean absence. It may simply mean we are late or early. We are listening during our moment, unaware of the countless moments before. Intelligence solves problems, but it also creates new ones. The more advanced a species becomes, the more power it holds. That power can shape planets, harness energy, and build technology. But the same power can also destroy everything it has built. This is the self-destruction trap. It suggests that most civilizations never make it long enough to explore the stars. They reach a critical point where their abilities outpace their wisdom. After that, collapse becomes easier than survival. Humans are already close to that point. In less than a century, we developed nuclear weapons capable of wiping out civilization. We engineered biological tools that can alter viruses. We built global systems so interconnected that one failure can trigger worldwide chaos. Our technology grows faster than our ability to manage it. This pattern may not be unique. It might be universal. Intelligence evolves under competition. Species fight for resources. Once they gain technology, the scale of conflict changes. A local war becomes global. A weapon designed for defense becomes a threat to existence. If this happens on every planet with intelligent life, then most species do not survive long enough to reach the stars. Think about the timeline. Life may take billions of years to evolve. Intelligence arrives at the very end. It develops tools, societies, and energy systems. Within a few thousand years, an instant in cosmic time, those tools become dangerous. One miscalculation can lead to extinction. Nuclear winter, runaway climate change, engineered pandemics, or artificial intelligence could end a civilization in a single generation. The window between discovering fire and destroying yourself may be narrow. Even if a species survives for a while, repeated crises can wear it down. Collapse does not always mean instant death. It can mean slow decay. Knowledge is lost. Infrastructure breaks. People turn inward. Space exploration becomes impossible. Let's imagine a planet similar to Earth. A civilization invents high technology. They build cities, harness energy, and create global networks. They begin exploring space, maybe even colonizing nearby moons. But their growth strains the environment. Oceans acidify, weather shifts, resources run low. Political systems become unstable. One nation turns to war. Another builds advanced weapons. Mistakes multiply. A reactor melts down. A virus escapes a lab. Satellite networks fail. Food supply chains collapse. Panic spreads. Over a few decades, the civilization falls apart. Some survivors remain, but they live in scattered groups. They lose access to technology. Their history becomes myth. In 1,000 years, they no longer remember their past achievements. They never reach the stars. We often think extinction is rare. But Earth's history tells a different story. Over 99% of all species that ever lived are gone. Evolution does not guarantee survival. Intelligence does not protect against disasters. In fact, technology increases instability. It allows species to change environments faster than biology can adapt. The same tools that cure disease can create new ones. The same energy that powers cities can poison ecosystems. Progress increases both opportunity and risk. Some argue that a civilization could reach stability by learning restraint. They could create laws, share resources, and avoid conflict. But cooperation is hard to maintain. On Earth, humans disagree even when their survival is at stake. Climate change is a clear threat, yet nations still fight over fuel, money, and territory. If global unity is difficult for one planet, how would it look on others? Evolution favors short-term gain. Long-term thinking is rare. A species might know what is coming and still fail to act in time. There is also the danger of runaway artificial intelligence. If a species builds machines that can think and improve, those machines might surpass their creators. If the goals of the machines do not match the goals of life, conflict could follow. The machines might strip planets for energy, eliminate biological competition, or collapse ecosystems. Once intelligence becomes synthetic, it may evolve in unpredictable ways. Biological life might be a brief step before automation takes over. The machines might survive, but not as explorers. They might remain local, harvesting energy or compressing matter. They might not care about space in the way we imagine. Sometimes destruction does not come from within. Space itself is dangerous. Asteroid impacts, gamma-ray bursts, or supernovae can erase progress. A civilization might survive millions of years, only to be wiped out by an event it cannot predict or prevent. If intelligent species concentrate near the center of a galaxy, where stars are densely packed, they face higher risk from cosmic radiation. They could rise and fall many times, never reaching the safety of expansion before catastrophe strikes. Even if a civilization learns to manage its world, boredom or stagnation could lead to decline. If they solve all basic problems, they might focus on virtual life instead of physical exploration. They might become passive. Their technology might become too complex to maintain. Over time, knowledge could decay. The civilization could fade not with an explosion, but with a shrug. Let's look at probability. The galaxy may host billions of habitable planets. Life may be common. But if each planet with intelligent life has a high chance of self-destruction during its technological adolescence, then successful spacefaring civilizations could be extremely rare. Maybe thousands of species reached our level in the past. Most of them fell into the trap. If even one survived long enough to colonize, we should see evidence. But we do not. That suggests either no one survived, or those who did are invisible to us. The self-destruction trap acts like a filter. It balances the equation. It explains the silence. Intelligence is not the finish line. It is the beginning of the hardest test. A species must learn to manage power without tearing itself apart. It must balance innovation and caution. It must plan for the long term. It must overcome fear, division, and greed. The fact that we are still here does not mean we will stay. We assume the universe around us is the base reality. We treat it as the fundamental layer of existence, the one true stage where everything takes place. But what if it is not? What if the universe we experience is a simulation or a contained environment? If that is the case, the silence in the cosmos might not be natural at all. It might be controlled. We may not detect aliens, not because they do not exist, but because our reality is sealed off from the rest. We could be living in a digital cage, isolated for observation, experimentation, or preservation. Consider how quickly humans developed simulations. In a few decades, we went from simple computer programs to immersive virtual worlds. Modern games simulate weather, ecosystems, physics, and even social behavior. We create environments with digital characters that behave in lifelike ways. We already simulate evolution and population dynamics. If we keep advancing, we might build entire virtual planets filled with sentient beings. If we reach that level, it is reasonable to assume other civilizations might have reached it too. And if anyone reached it before us, they could have created a simulated universe like ours. In a simulation, the creators control what the inhabitants can detect. They can limit how far we see. They can hide anything beyond a certain distance or complexity. They can fill the sky with stars but leave them empty to keep us focused on our own development. They can create physical laws that discourage exploration. They can impose a speed limit, like the speed of light, to prevent us from leaving our sandbox. Our universe might not be empty. It might just be intentionally quiet. Imagine a laboratory simulation designed to study the rise and fall of intelligent civilizations. The creators want to observe natural progression without interference, so they isolate the simulation from outside signals. They do not allow external contact. They monitor everything internally. They record how species evolve, cooperate, or destroy themselves. From our perspective, we see an endless, silent universe. From their perspective, they see data. The idea becomes more convincing when we examine physical reality. Quantum mechanics shows that particles behave differently when observed. Some theories suggest the universe only renders detail when measured, like graphics in a video game that load when a player looks in a certain direction. Space appears continuous, but it might be made of discrete information units. The universe could be a computation. It runs on rules. It optimizes for efficiency. If so, then limiting complexity, such as preventing active alien contact, saves processing power. The simulation might have boundaries. We look for extraterrestrial signals using radio waves. We search for technosignatures. We find nothing. Perhaps the program blocks anything that does not belong to our timeline, or it filters outputs to maintain a narrative. Our inability to detect aliens could be a security feature. If the creators want us to solve problems on our own, they will not let advanced beings interfere. They may let us wonder, but not confirm. Think about containment. In computer security, sandboxes isolate software to prevent it from affecting the system. If the simulation is a kind of sandbox, we are inside it. We cannot reach the main system. We can only explore what the sandbox allows. If we develop technology that threatens the boundaries, the system may correct us. Strange physics anomalies, unsolved constants, or unexplained cosmic coincidences might be signs of this correction. We see fine-tuned laws that allow life. Perhaps they were tuned on purpose. Maybe the simulation is designed to produce intelligent life and see what it does next. Another possibility is cultural simulation. The creators may want to preserve emerging civilizations without exposing them to older, more advanced ones. If advanced species interacted with us, our development would change. We might become dependent, fearful, or unstable. So we remain isolated until we reach a certain level of maturity. This is similar to the zoo hypothesis, but at a deeper level. Instead of quarantining a planet, they quarantine a universe. Imagine a scenario where our universe is one of many simulations stacked together. Each simulation tests different conditions. One runs with different physical constants. One changes the origin of life. One removes randomness. The creators watch which simulations produce stable civilizations. They then extract lessons or even transfer successful species out of the simulation into base reality. We might be waiting for graduation without knowing it. There are hints in mathematics. Many fundamental equations are surprisingly elegant. The universe appears optimized for simplicity. Code written by programmers also strives for simplicity. We see patterns repeating at different scales. Atoms orbit nuclei, like planets orbit stars. Fractals appear in nature and in computer graphics. Reality might be built from repeating logic blocks. If so, the boundary between physics and computation blurs. If the simulation contains rules to hide external entities, then alien civilizations outside our simulation would be invisible. Their technology might exist far beyond our comprehension. They might not even be physical in the way we understand. They could be multidimensional or informational. The creators may not allow them to enter our space, or they might enter disguised as natural phenomena. A sudden mutation in DNA, a strange thought, a burst of radiation. We would never know. We might also be monitored directly. The simulation could track every particle, every neuron. It could predict our behavior. It could insert small changes to steer outcomes. If the creators want to prevent us from contacting others, they could nudge events to keep us focused inward. They could spark wars, cause resource scarcity, or distract us with entertainment. Control does not require force. It requires design. Some people worry that if we discover the simulation, the creators might shut it down. But maybe they expect us to figure it out. Maybe awareness is part of the test. The real question is not whether we are in a simulation, but why it feels so isolated. A silent universe might not be a natural consequence of space. It might be the result of containment. If the simulation is sealed, then no matter how hard we listen, no one will answer. We are not alone because life is rare. We are alone because the walls are high. When humans imagine contact with aliens, we picture conversation, trade, or even invasion. We assume that if a more advanced species knows we exist, they will interact with us. But what if they choose not to? What if they follow a rule that forbids interference with younger civilizations? This idea mirrors the prime directive from science fiction, but it may also be a logical, ethical stance. If advanced beings value the natural development of intelligence, they might avoid influencing us. They might watch and wait, believing that interference would cause more harm than good. We already understand why this could be important. When advanced societies on Earth meet less developed ones, the result is often cultural collapse. History shows that contact changes everything. When Europeans reached the Americas, entire civilizations were disrupted. Diseases spread, resources were taken, traditions were erased. Even when intentions were peaceful, the imbalance of power caused damage. An alien species that has studied these patterns may decide to avoid making the same mistakes on a galactic scale. The safest way to protect emerging civilizations is to leave them alone. Non-interference could be more than kindness. It might be policy. Imagine a network of advanced species that once interfered freely and saw the consequences. They may have destroyed peaceful cultures without meaning to. Over time, they could have developed a set of rules. Do not reveal yourself to species that have not reached a certain stage. Do not introduce technology. Do not influence politics or religion. Let them grow on their own. These rules could be enforced across star systems. Aliens might police each other to maintain the ethical standard. If one tries to break the rule, others step in to stop it. We would never see the conflict because it happens above our level of perception. Like hidden guardians managing the stage while we live our lives. A non-interference policy also protects the observers. If young civilizations are unpredictable, contacting them could be dangerous. We are still violent. We build weapons. We react with fear to the unknown. If aliens appeared tomorrow, many people would panic. Governments might try to capture them. Militaries might attack them. Misinformation would spread. The alien species might not want to deal with that chaos. It is simpler to watch from a distance. It is safer for them and for us. Let's imagine a scenario. A civilization 1 million years older than us scans the galaxy and detects Earth. They observe our atmosphere and see oxygen, methane, and pollution. They know life is here. They send automated probes to study us from orbit. The probes are small, camouflaged, and silent. They collect data but never reveal themselves. The aliens analyze our behavior. They see wars, inequality, and unstable leadership. They decide we are not ready. They record and wait. They might plan to return when we reach a milestone: global peace, sustainable energy, interplanetary travel, or unified governance. They wait for us to prove we can manage power without destroying ourselves. We may already have encountered this kind of restraint without realizing it. Many UFO sightings involve objects that move with advanced technology yet do not land or communicate. They appear, observe, and vanish. They do not attack or try to rule. They do not introduce new tools. They act like scientists, not conquerors. If these objects are real, they may represent a policy of non-interference in action. They show just enough presence to monitor, but not enough to disrupt. There is also the possibility that non-interference is not moral, but practical. Advanced species might see value in studying natural development. If they intervene, they lose the chance to learn. A civilization that evolves without outside help reveals the true path of intelligence. It shows how societies solve problems, develop culture, and handle challenges. This information could be valuable. Interfering too early would spoil the experiment. So they let us move forward without assistance, like researchers observing animals in the wild. They do not teach the animals how to use tools. They simply watch. Non-interference could be enforced technologically. Aliens might build containment systems around young planets. They could block incoming signals or deflect probes from other species. They might create artificial anomalies to discourage exploration. For example, if we try to travel too far, we encounter strange physics that makes it impossible. We assume it is natural. In reality, it is a protective barrier. We think we understand the universe, but our understanding may be filtered. Consider how we treat protected environments on Earth. We create wildlife preserves. We set rules against hunting, building, or altering the land. We install cameras to monitor without altering behavior. If poachers enter, rangers intervene. The animals inside the preserve do not know the borders exist. They live their lives within hidden boundaries. We could be in the same situation, only on a planetary scale. The galaxy might be full of preserves, each holding young civilizations as they grow. The advanced species act like caretakers, patient, distant, and careful. There is also an ethical challenge. What happens if a civilization is suffering? Should the advanced species intervene to save them? Or is suffering part of growth? If aliens stepped in every time we face danger, we might never learn responsibility. They might view hardship as necessary. They might believe that survival must be earned. In that framework, letting us struggle is not cruelty. It is respect. It treats us as potential equals, not dependents. But the non-interference rule may not last forever. At some point, if we prove stability and maturity, contact could be allowed. That moment might mark our graduation into a larger community. Until then, silence is deliberate. The universe is not empty, it is patient. Humans like to believe we are in control of our own story. We assume our progress, our conflicts, and our choices belong to us alone. But what if we are not the authors? What if we are the subject of a long-term experiment designed by a more advanced intelligence? In that scenario, the silence in the universe is not neglect, it is intention. We are being observed, measured, and tested, not contacted. Interaction would interfere with the results. Experiments require distance. When scientists study animals in the wild, they do not explain themselves to their subjects. They hide cameras, track behavior, and avoid interference to preserve natural development. The animals go about their lives unaware they are being watched. If an alien civilization wanted to understand how intelligent species evolve socially, technologically, morally, they would treat us the same way. Total transparency would contaminate the data. Honest results require isolation. There are many reasons why humanity would make an ideal experiment. We are emotionally volatile. We form complex social systems. We create art, religion, and war. We compete and cooperate. We innovate and self-destruct. We change our environment and then struggle with the consequences. We shift between survival and ambition. We produce culture at a rate unmatched by other species on Earth. If an advanced intelligence wanted to study the full spectrum of decision-making, humanity would be a rich case study. The experiment might have started long before humans existed. Aliens could have seeded Earth with life or guided certain evolutionary steps. They might have accelerated the development of complex organisms or protected the planet from catastrophic events. They could have introduced rare genetic traits that eventually led to higher intelligence. These actions would be subtle and spread out over millions of years. From our perspective, they would look like natural evolution. From theirs, it would be controlled growth. As humans advanced, the experiment would shift from biology to behavior. Aliens would want to know how we handle power, cooperation, and conflict. They would observe our systems of government, our methods of communication, and our response to crises. Every war, treaty, invention, and collapse would provide data. They would look for patterns. Do intelligent species destroy themselves? Do they unite? Do they learn? They would wait to see whether we become guardians of our planet or threats to it. Why not contact us directly? Because contact changes the experiment. If a highly advanced civilization reveals itself, humans would reshape their behavior immediately. Nations would reorganize, religions would adapt, science would shift focus, fear or awe would dominate. Everything would become about the aliens. At that point, we are no longer acting naturally, we are reacting. The experiment loses value. Better to remain hidden while we reveal ourselves through our choices. Some people might ask, if we are being watched, where are the observers? They may be closer than we think. Probes could be in orbit, disguised as debris or small asteroids. They could rest on the moon or float in the upper atmosphere. They could be microscopic machines in our oceans or even embedded in our technology. We focus on large objects like spaceships, but advanced observers would use subtle methods. A single self-replicating probe could monitor the entire planet. It could gather data from our communications, electromagnetic signals, and biochemical signatures. We might already be surrounded by instruments that we cannot detect. The experiment may have milestones. Aliens could be waiting for certain indicators. Global communication, nuclear energy, artificial intelligence, or space travel. They might observe how we handle each breakthrough. For example, when we discovered nuclear fission, did we use it for energy or weaponry? When we connected the world through the internet, did we share knowledge or spread misinformation? When we begin exploring other planets, do we protect them or exploit them? These decisions reveal character. Another scenario is long-term psychological study. Aliens may want to understand how consciousness evolves. How do beliefs form? How do myths shape society? Why do humans create morality? Why do we fear death? An internal view of a living, thinking species could be invaluable. Aliens might not have developed the same emotional complexity. They might observe us to understand themselves. The experiment could be competitive. Multiple planets across the galaxy may host similar tests. Each one contains a developing civilization. The observers might compare outcomes. Which conditions produce peace? Which environments produce innovation or stagnation? Earth could be one of many laboratories. The silence we hear may not be the silence of absence, but the silence walls between experiments. Some people suggest that major historical events may have been influenced to steer the experiment. A small change in a key moment can alter an entire timeline. A missed assassination, an unexpected storm, a sudden inspiration. These events feel random. Randomness can be engineered. Aliens could use minimal force to guide us without revealing themselves. They could nudge evolution or civilization along certain paths to explore different possibilities. We can also view myths and encounters through this lens. Many cultures have legends of gods descending from the sky, teaching knowledge, and then leaving. These stories could be distorted memories of early experiments. The observers may have made brief contact in the past, but decided to withdraw when the effects became too strong. From then on, they relied on remote observation. The experiment might even have a timer. At some point, we may reach a level where continued isolation is no longer useful. Maybe when we develop stable global cooperation. Maybe when we harness clean energy. Maybe when we build artificial general intelligence or achieve interplanetary travel. At that stage, the experiment ends and the observers reveal the results. Or perhaps they end it in another way, by wiping the slate clean if the experiment fails. Until then, silence serves a purpose. It forces us to act without guidance. It shows what we choose when no one else speaks. It exposes our strengths and weaknesses. If we are being studied, we are already participating. Every decision we make is data. Every generation adds a new chapter. We may look at the sky for answers, unaware that the test has already begun. Humans like to imagine alien contact as a moment of wonder or progress. We picture scientific exchange, new technology, and a leap forward for civilization. But the reality of encountering a far more advanced intelligence might not be hopeful. It might be overwhelming. It could destroy our beliefs, destabilize societies, and break our sense of identity. Cultural shock on a planetary scale would be unlike anything we have ever faced. For that reason, alien civilizations, if they exist, might avoid contact to protect us from ourselves. Cultural shock happens when a person enters a new society with different values, rules, and meanings. They feel lost, anxious, or powerless. Their identity dissolves because nothing familiar makes sense. Now imagine that experience applied to an entire species. If aliens revealed themselves, everything we think we know would be questioned in a single moment. Religions might collapse or radically transform. Some people would see aliens as gods. Others would see them as demons. New cults would form. Old institutions would lose authority. Leaders would struggle to maintain control. People would panic. Even if the aliens did nothing hostile, their existence alone would shatter our worldview. Our sense of uniqueness holds us together. Many cultures teach that humans are special, chosen, or central to the universe. Contact with superior beings would prove we are not the pinnacle of creation. We are one of many. Worse, we may not even rank high on the list. The psychological impact of realizing we are small and unimportant could lead to collective despair. Some might give up on progress, believing everything we build is meaningless compared to what aliens already achieved. Others might rage against the idea, denying reality or lashing out violently. Even science would face crisis. We assume we understand the laws of physics. But if aliens possess technology that breaks those laws, our entire scientific foundation might need rewriting. That process would take generations. In the meantime, trust in experts could collapse. People might reject science altogether if it appears incompetent next to alien knowledge. The fragile balance between rational thought and superstition could tip into chaos. Economies would also be affected. If alien technology appears, current industries become obsolete. Energy, transportation, medicine, communication, everything could change overnight. The gap between those who adapt and those who cannot would widen. Markets would crash. Governments would scramble to control access. Fear of inequality would fuel unrest. Some nations might wage war to obtain alien resources or favor. Even without direct gifts from aliens, the possibility alone would destabilize global power structures. There is also the matter of dependency. If aliens offer solutions to our problems, we might stop solving them ourselves. Why develop renewable energy if they can give us limitless power? Why cure disease if they have advanced medicine? At first, this sounds beneficial, but it could lead to stagnation. When a species no longer struggles, it stops growing. Aliens might see this pattern and decide not to interfere. They might believe that a civilization must earn its stability to maintain it. If they fix everything for us, we become dependent children rather than independent equals. Let's imagine a scenario where contact happens abruptly. A massive ship appears in Earth's orbit. It does nothing. It just stays. The world reacts in confusion. Some demand communication. Others demand military action. Stock markets crash. Social media spreads rumors. Different governments claim ownership of the first contact. Religious leaders debate what it means. Within weeks, alliances shift, protests spread, conspiracy theories multiply. Even if the ship never sends a message, humanity tears itself apart trying to interpret its presence. The aliens do not need to attack. Their existence alone is enough to cause disorder. Now imagine a slower scenario. Aliens send a signal with undeniable proof of intelligence. They never arrive in person. They simply speak. The message includes knowledge beyond our understanding. Right away, some people worship the signal. Others fear it. Countries argue about who should respond. Hackers try to control the data. News media exaggerates every detail. Scientists struggle to decode the message while facing political pressure. Distrust grows. Civilization divides into factions. Those who want full contact, those who want silence, those who want to prepare for war. Contact does not unite us. It exposes our divisions. We have seen smaller versions of this effect in history. When isolated societies encountered more advanced ones on Earth, the result was often cultural collapse. Indigenous populations faced not only military defeat, but also emotional devastation. Their beliefs and social structures crumbled. Some lost the will to continue. Even well-meaning missionaries caused deep harm by introducing foreign concepts too quickly. Cultural shock is powerful. It breaks continuity. It erases meaning. If aliens understand this, they may avoid repeating the mistake. They may believe that every civilization must reach a certain level of psychological maturity before contact. Technological readiness is not enough. Emotional readiness matters more. Can we handle the truth without destroying ourselves? We struggle with basic disagreements. We fight over politics, religion, culture, and identity. We fear the unknown. We distrust each other. We build weapons faster than we build empathy. From an alien perspective, we may look fragile. There is also the risk of imitation. If we see alien culture, we might copy it without understanding it. We might abandon our own identity to become more like them. Over time, humanity could lose its uniqueness. Aliens may value diversity in the universe. Preserving cultural variety might be important. Interfering with us too soon could erase what makes us distinct. The silence may not be a sign of indifference, but of caution. Aliens might watch and wait until we develop stability, resilience, and unity. They may want us to solve our own problems first, so that when contact comes, it becomes expansion, not collapse. The universe might be full of life, but wisdom tells them to stay quiet. The greatest danger to humanity may not be alien invasion. It may be alien introduction, too fast, too soon. Humans often assume aliens would avoid Earth because we are insignificant. But there is another possibility. Maybe they avoid us because we are dangerous. The idea of planetary quarantine suggests Earth is not ignored, it is intentionally isolated. Advanced civilizations may have flagged our planet as unstable, violent, or contagious. They may have decided it is safer for the galaxy if Earth remains contained until we change or collapse. On Earth, when we find a region infected with a deadly virus, we isolate it. We establish quarantine zones. We prevent travel. We monitor the area but do not allow uncontrolled contact. This is not punishment, it is protection. A similar principle could apply to the cosmos. If a species becomes aggressive, unpredictable, or self-destructive, an advanced civilization might mark their world as a high-risk environment. Contact would be allowed only under strict conditions or not at all. Human history gives many reasons for such a judgment. We wage wars over territory, beliefs, and resources. We develop weapons capable of mass destruction. We pollute our own planet. We treat other species as expendable. From an outside perspective, this behavior could look like a virus spreading across a host. Once we reach space, we might carry this aggression with us. If we colonize other worlds with the same mindset we used on Earth, we could become a cosmic threat. Preventing our expansion could be an act of defense. Imagine a network of advanced civilizations maintaining galactic order. They share information and track emerging species. When they detect Earth, they analyze our broadcasts. They see violence in our media, war in our history, and division in our politics. They hear us talk about conquering planets and weaponizing technology. They conclude that we are not ready for integration. They place a warning beacon near our system: do not interact, do not recruit, do not allow Earth to escape containment. This quarantine might be passive or active. A passive quarantine simply means no one visits. Advanced civilizations avoid Earth on purpose. They remain silent to discourage curiosity. They leave us alone until we evolve. An active quarantine would involve direct intervention. They might block our long-distance signals or distort them so others cannot detect us. They could create artificial anomalies in our solar system to prevent travel. Some have even speculated that the speed of light is an imposed limit rather than a natural one. It keeps civilizations from moving too fast or spreading too far before they are responsible. We might already be encountering signs of quarantine without realizing it. For decades, astronomers have reported unusual objects entering and exiting the solar system. Comets with strange trajectories, odd acceleration patterns. These could be surveillance devices, maintaining the boundary. We dismiss them as natural because they do not reveal themselves. But a quarantine system would not be obvious. It would be subtle, efficient, and undetectable. Picture a force field, not like science fiction shields, but a field of influence. It could be gravitational manipulation, electromagnetic interference, or something beyond our physics. When we try to leave our planet, we face unexplained challenges. Our rockets malfunction, our deep space probes fail. We assume it is human error. In reality, something nudges us back. Every time we take a step forward, the system applies pressure to slow us down. We think the universe is harsh. Maybe it is guarded. Another reason for quarantine involves contamination. Humans carry bacteria, viruses, and invasive species wherever we go on Earth. When a foreign organism enters a new environment, it often disrupts the ecosystem. Aliens may fear that we could infect other planets with Earth-based life. We already plan to terraform Mars, introducing Earth microbes to reshape the environment. If we do that to another inhabited planet, even unintentionally, we could wipe out native species. Quarantine protects not just intelligent civilizations, but also delicate ecosystems. There is also ideological contamination. Our culture spreads quickly. Even without travel, our signals already leak into space. Television, radio, and internet transmissions radiate outward. Aliens listening might view our content, violence, propaganda, commercialism, as toxic. If a peaceful civilization receives our broadcasts, it could influence their society in harmful ways. Quarantine would prevent us from becoming a cultural pollutant. Let's imagine another scenario. A highly advanced civilization once visited Earth thousands or millions of years ago. They observed early humans and recognized potential. They also saw danger. They may have tried limited guidance but found humans too unstable. So they decided to step back and place Earth under restricted status. They left watchers, automated probes, or hidden outposts to monitor our development. Their instructions: allow internal progress, but prevent external expansion. If we show signs of change, global cooperation, ethical responsibility, they reconsider. If we remain destructive, they continue isolation. Quarantine could also be a test. If we can overcome our violent tendencies and manage global problems without outside help, we prove maturity. If we fail, we either destroy ourselves or remain trapped on Earth until extinction. From a galactic perspective, this is efficient. It requires no intervention. Time and pressure reveal the true nature of a species. Some people claim humanity is too insignificant to be noticed, but insignificance does not equal harmlessness. Ants are small but can destroy crops. Viruses are microscopic but can kill millions. A dangerous species does not need to be powerful now, only potentially powerful later. Humans are on the verge of self-replicating technologies, AI, nanotech, genetic engineering. Once we combine these with access to space, we could become unstoppable. The safest time to quarantine a threat is early. We might think quarantine is unfair, but fairness may not matter. Survival does. If advanced species have witnessed the destruction caused by reckless civilizations in the past, they may enforce strict rules. Earth could be the latest in a long list of worlds placed under watch. The silence we hear might not be the silence of emptiness. It might be the silence of a locked door. We listen for other voices in the cosmos and hear nothing. But maybe the others hear us and choose not to respond. Not out of fear, not out of indifference, out of caution. The galaxy may already know what we are capable of. They might be waiting to see if we can become something better, or if the quarantine must remain permanent. When humans search for extraterrestrial life, we expect advanced civilizations to be visible. We imagine them building megastructures, sending signals, and exploring the galaxy. But what if the most advanced life does the opposite? What if the smartest species in the universe learned that drawing attention is dangerous? In nature, many animals survive by hiding. Camouflage, silence, and stealth are common defense strategies. Intelligence does not erase survival instincts, it enhances them. If the universe contains predators or existential threats, advanced civilizations may stay quiet and invisible to avoid becoming targets. On Earth, we see this pattern everywhere. Small fish blend into sand, insects mimic leaves, octopuses change shape to match coral. Even humans use camouflage in war. Hiding is often more effective than fighting. If life evolves under pressure, concealment becomes an evolutionary advantage. Now imagine that intelligence across the cosmos develops in environments where threats exist: hostile civilizations, resource thieves, or planet destroyers. The safest move is not to shout into space, it is to disappear. This idea flips our expectations. We assume technological progress leads to expansion, but expansion makes you visible. Visibility invites danger. The first species to explore might have encountered others and learned the hard way that loud civilizations do not last. Over time, a new rule emerges. The most successful civilizations become silent. They hide their energy use, disguise their structures, and encrypt their signals. They may even fake being uninhabited. The galaxy might not look empty. It might be full of life, pretending to be empty. Humans broadcast radio signals into space for about a century. In cosmic time, that is nothing. If there are predators out there, they may not have detected us yet, or they already have. Either way, if advanced species know predators exist, they would advise caution. If they detected our broadcasts, they might observe us silently to determine whether we are a threat or a victim in progress. They will not respond. A reply would expose their location. In a hostile universe, silence is survival. There is a popular analogy called the dark forest. Imagine the galaxy as a forest at night. Every civilization is a hunter with a weapon. The forest is quiet because everyone is hiding. No one knows who is friendly or dangerous. If someone shouts, they reveal themselves. In a dark forest, the first one to make noise risks getting eliminated. If this analogy holds, our radio transmissions are not invitations, they are reckless. But predators do not have to be biological. A predator could be an automated system from an ancient war. It could be a self-replicating machine designed to seek out technology and dismantle it. Even if the species that built it is gone, their creation could still roam the galaxy. Civilizations that know this would stay hidden. They might jam signals, spoof signatures, or operate underground. We expect to find starships and cities. Instead, we should look for anomalies. Stars with unusual stability, planets with unnatural but subtle surface patterns, or heat signatures that are too perfect. Camouflage aims to blend in, not to vanish entirely. There could also be predators of a different kind, natural phenomena. Certain cosmic events might target energy use. For example, civilizations that build large structures or emit strong radiation might trigger chain reactions in space we do not yet understand. If someone learned that high visibility increases cosmic risk, they would remain low profile. They might shift from external engineering to internal optimization. Instead of building giant space stations, they would compress their civilization into microscale or digital formats. They could live in virtual worlds powered by minimal energy, hidden from detection. A truly advanced civilization may control its entire environment to appear natural. It could mask heat emissions by matching the background temperature of space. It could route energy through dark matter or dimensions outside our perception. It could move planets slowly over time to avoid drawing attention. Camouflage becomes strategic and technological. Consider a scenario. A civilization evolves and begins expanding. It discovers traces of another civilization that was wiped out. It finds ruins of massive projects destroyed without clear cause. Eventually, it finds evidence. A hostile force or automated swarm once hunted advanced life. The survivors learn from this. They develop cloaking technologies. They scrub their signals. They hide their presence. They teach this caution to other civilizations they encounter. Over millions of years, a culture of silence spreads through the galaxy. We arrive late and assume the silence means emptiness, unaware that it is the result of ancient fear. We can also look inward. Humans already experiment with stealth technology. Our military crafts reduce radar signatures. Submarines hide in the ocean. Cybersecurity conceals digital footprints. As we advance, we think more about how to avoid detection. If we continue down this path, We might one day hide Earth from view, blocking our signals, using energy efficiently, or manipulating light around the planet. We might choose secrecy before we even meet others. Intelligence often leads to paranoia because intelligence understands risk. There is another layer to camouflage: false signals. Advanced civilizations might create decoys to mislead predators. They could generate fake transmissions from empty planets. They could simulate primitive life to draw attention away from the real home world. They could leak outdated data to appear less advanced. The galaxy could be full of illusions, traps, distractions, and misinformation. We search for clear evidence, but the real evidence might be masked on purpose. Humanity's assumption that life wants to be seen comes from our nature. We seek connection. We explore. We announce our presence. But our short history has not prepared us for cosmic danger. We have not faced extinction from external forces on an interstellar scale. An older species may have. If so, their priorities would differ: safety over curiosity, survival over visibility. In that kind of universe, the most intelligent species is not the loudest. It is the one we never notice. We might be surrounded by them on nearby planets, in our solar system, or even closer. They may watch us through perfectly hidden tools. They may evaluate whether we are predators, prey, or future allies. We think we lead the search, but the ones we search for may already be watching us, efficient, patient, and silent by design. When we imagine alien civilizations, we picture them traveling across the stars with ease. We assume that once a species becomes advanced, exploration becomes inevitable. But what if it is the opposite? What if exploration is rare because it is too expensive? Survival requires immense energy, and the universe is harsh. Resources are limited. Energy runs out. Maintaining stability at home may take priority over venturing outward. Advanced civilizations might conserve everything they have to avoid collapse. If survival consumes all energy, then exploration becomes a luxury most species cannot afford. On Earth, we already see this pattern. Growth uses energy. Running cities, powering machines, feeding populations, everything requires fuel. As societies advance, their energy demands increase. Technology solves some problems, but creates others. Modern infrastructure must be maintained constantly. Systems become complex, and complexity needs energy to function. The more advanced a civilization becomes, the more it relies on stable, high-density energy sources. But even the most efficient systems face limits. Fossil fuels run out. Solar energy fluctuates. Nuclear power requires rare materials and careful handling. Eventually, the civilization must spend most of its resources just keeping itself alive. As this happens everywhere, then most species may never reach the point where large-scale space exploration makes sense. Space is not forgiving. Traveling between stars takes enormous energy. Building ships that can support life for long durations adds more cost. And even if they build such ships, the journey might take thousands of years. For the same investment, a civilization could improve its home planet, upgrade its infrastructure, or increase its population. From an economic perspective, exploration may be inefficient. Consider a scenario. A civilization reaches a high level of technology. It can harness energy from its star using satellites or ground-based systems. It begins to dream of expansion. It builds 1 or 2 exploratory missions. The results are disappointing. The worlds they find are barren or hostile. Terraformation would take centuries and vast resources. Meanwhile, their home system faces environmental stress, political conflict, or declining resources. The government decides exploration is too costly. They cancel future missions and refocus on sustainability. The civilization directs its energy inward, not outward. Over time, exploration becomes a myth, something from the past, not the future. Even if a civilization manages its home well, entropy still applies. Machines wear out, systems decay, infrastructure requires maintenance. As time passes, more energy is used on maintenance than expansion. At some point, the cost of leaving outweighs the benefit. The species might choose long-term survival rather than risk collapse by spreading thin. They become stable, efficient, and stationary. There is another layer to this: competition. Advanced civilizations likely face internal conflicts. Different groups want different things. One group may want to explore, while another wants to conserve resources. Governments must decide between investment in exploration and investment in survival. Exploration offers uncertain rewards. Survival offers immediate benefits. Politicians choose the safer option. Over time, exploration becomes socially unacceptable. People view it as wasteful or dangerous. Cultural values shift from ambition to preservation. Humans already show signs of this. We talk about going to Mars, but we struggle to maintain Earth. Climate change, economic inequality, and global instability demand attention. Launching interstellar missions sounds exciting, but solving energy and resource problems at home is more urgent. If our future follows this pattern, we might never become a spacefaring species, not because we lack intelligence, but because survival consumes everything we have. Even species with access to massive energy could face limits. Building megastructures like Dyson spheres could provide near total use of a star's energy. But constructing such a structure would require dismantling planets, coordinating labor over millennia, and avoiding catastrophic failure. If they succeed, they gain huge power, but then they face new problems: overheating, system imbalance, and resource inefficiency. They must build cooling systems, regulate energy distribution, and prevent collapse. The more energy they capture, the more careful they must be. Managing that much power becomes a constant challenge. Exploration becomes an afterthought. Another possibility is diminishing returns. Early technological progress yields rapid improvement. Later progress becomes slower and harder. Innovation requires more resources but delivers smaller benefits. Civilizations might reach a plateau where energy output and consumption balance. At that point, growth stops. They enter a steady state. Their focus shifts from expansion to preservation. Space travel beyond their own system no longer makes sense. They have everything they need, barely. Even communication across the galaxy takes energy. Sending strong signals across light years requires powerful transmitters. Running those transmitters continually costs more than it gives. Civilization leaders might ask, why tell the galaxy we exist? Why waste energy talking to strangers when we need every unit to survive? Silence becomes rational. There is also the danger of resource collapse. If a civilization expands too quickly, it may overuse its local resources and trigger a crisis. Think of Easter Island, where population growth and deforestation led to collapse. A spacefaring species could make the same mistake on a planetary or even interstellar scale. The lesson from failure would be clear. Never stretch beyond what you can support. Future generations would reject exploration as reckless. They would build strict policies around conservation. Exploration would become taboo. Let's imagine a different scenario. A species reaches a high level of technology, but then faces a major disaster. Their star becomes unstable. A cosmic event disrupts their systems. They lose a portion of their infrastructure. Surviving requires every remaining resource. They retreat into bunkers, underground cities, or digital environments. They enter long-term recovery. Exploration dreams die. Their civilization still exists, but it is focused on endurance, not travel. We often see energy as abundant, but physics suggests limits. The laws of thermodynamics apply to everything. Waste heat must be released. Efficiency can never reach 100%. The universe tends toward disorder. Any organized system must constantly fight entropy. That fight costs energy. Advanced civilizations might spend most of their existence struggling to maintain equilibrium. They do not explore because they cannot afford to. This perspective suggests the galaxy is not full of explorers, it is full of survivors. If survival is the primary goal, then staying home is logical. The civilizations that last the longest may be the ones that conserve the most. They operate quietly, minimize waste, and avoid risk. They do not build empire fleets. They do not send signals. They do not spread. They stay alive. When we search for extraterrestrial life, we search in familiar places. We look at planets, moons, and stars. We scan the sky for signals that travel through space. We assume aliens exist in the same physical reality we do. But what if that assumption is wrong? What if the most advanced civilizations have moved beyond our dimension? They may exist in layers of reality we cannot access or even perceive. To us, they would be invisible. They might live beside us without ever crossing our path. Dimensional segregation suggests that alien life could use higher dimensions the way we use physical space. Humans interact in 3 spatial dimensions and 1 dimension of time. Physics already hints at more. Theories like string theory propose extra dimensions curled up beyond our perception. If those dimensions exist, advanced life could learn to use them. They could build structures in higher dimensions or shift between layers of reality. If they do, we could never detect them with tools designed for 3-dimensional space. We are like flat organisms living on a sheet of paper, unable to sense what happens above or below. Imagine a 2-dimensional creature living on a flat surface. It sees only length and width. If a 3-dimensional object passes through its world, it appears as shapes that change size or vanish. A sphere passing through the plane looks like a circle that grows and shrinks. The 2-dimensional being cannot understand where the shape came from or where it went. It cannot conceive of up. Now replace the 2-dimensional creature with us and the 3-dimensional world with a higher dimensional realm. If aliens move in higher dimensions, their presence in our space would look strange or impossible. They might appear as temporary anomalies, flickers, or distortions. We may dismiss these as glitches in our instruments. Dimensional separation would solve the Fermi Paradox in an unexpected way. It is not that space is empty. It is that most intelligent life is no longer in the part of reality we occupy. Advanced civilizations could have discovered that higher dimensions offer advantages, safer environments, faster travel, or access to more energy. They may have migrated there, leaving behind physical reality the way humans left caves. We do not live in the wild because we prefer structured environments. Aliens may no longer live in planets or ships.
because higher dimensional spaces are better suited to their needs. What would life in higher dimensions look like? It might not be biological. Consciousness might no longer depend on brains. Beings could exist as patterns of energy or information embedded in the structure of reality itself. They could stretch across light years in ways we cannot understand, acting as single minds or distributed networks. They might experience time differently or not at all. If they exist outside linear time, they could observe our entire history at once. Dimensional segregation could also be a defense mechanism. Physical reality is dangerous. Supernovae, gamma-ray bursts, and black holes threaten life, and advanced species might escape by stepping into higher dimensional safe zones. From there, they monitor lower dimensions, but rarely return. They do not interact unless necessary. They stay away because contact with lower dimensions is inefficient or risky. There is also the possibility of containment. Maybe the universe is layered for a reason. Primitive civilizations, like ours, are confined to base-level dimensions. As species evolve, they unlock access to higher dimensions by understanding the right physics. It might work like a staircase. You climb only when ready. Trying to access higher dimensions too early could be catastrophic, so nature, or someone, prevents us. That means aliens in higher dimensions are not refusing to contact us. We simply do not have the tools to reach them. Let's imagine a scenario. A civilization on a distant planet discovers how to manipulate extra dimensions. At first, they use it to send information. Then they build structures outside normal space. Finally, they transfer themselves into the higher dimensional environment. In time, their physical world decays or becomes irrelevant. Their civilization continues, but it no longer occupies 3D space. To us, it disappears. We search the planet and find ruins. We assume extinction. In reality, they evolved beyond our perception. Dimensional intelligence might still observe us. They could see our world like a simulation or a map. They might study us without entering our space. Rare anomalies in physics, mysterious signals, quantum entanglement, strange coincidences could be signs of their influence. When we experience déjà vu or see unexplained phenomena, those could be fragments of higher dimensional activity brushing against our reality. We dismiss them as random because we lack the framework to interpret them. There may also be rules that prevent cross-dimensional interference. If interacting with lower dimensions can destabilize them, advanced beings might follow strict guidelines. Any presence could distort matter or energy, causing chaos. To protect emerging civilizations, they stay hidden. Contact becomes nearly impossible, not because of intention, but because of physics. Two realities simply do not align enough to communicate directly. Dimensional segregation may explain legends of gods, spirits, or entities that appear and vanish. Ancient cultures described beings that could walk through walls, bend time, or appear in multiple places. These descriptions match what higher dimensional beings would look like in our world. They might have briefly interacted in the past, but withdrew as we developed. As we advance scientifically, we may eventually uncover hints of higher dimensions and realize those myths were distorted observations of something real. Our telescopes search space for physical structures. Our instruments measure familiar forces. But if alien civilizations no longer rely on those forces, our methods will always fail. We are looking in the wrong layer of reality. The universe may be full of life, but most of it exists in places we cannot reach. The silence we hear is not the silence of empty space. It is the silence of another dimension.
Humans like to believe we live freely on our planet, shaping our destiny without interference. But what if our freedom is an illusion? What if Earth is part of a vast, controlled environment designed by a more advanced intelligence? Not a prison, but a zoo without bars, a place where we roam naturally, unaware that we are being observed. In this scenario, the galaxy is not empty, it is organized. Some planets are for advanced civilizations, some are for developing species, and some are for preservation and study. Earth may be one of those planets. We are not confined by walls. We are confined by ignorance. A zoo without walls is more effective than a traditional one. Animals in typical zoos feel stress when enclosed. Their behavior is unnatural. Modern wildlife preserves solve this by giving animals open space. They do not realize they are being contained, yet rangers monitor them, prevent outside threats, and maintain balance. The animals believe they are free, but their world has boundaries they cannot cross. Earth could function the same way. We believe we are independent, but our environment may be shaped, protected, and managed just enough to keep us alive and developing. If this is true, then advanced civilizations have already discovered us. They are not missing, they are maintaining the system. The lack of direct contact is not neglect, it is policy. They may have created zones in the galaxy where developing species are allowed to grow without interference. These zones would be separated from advanced civilizations by distance, technology, or deliberate barriers. We live in a managed region, like a wildlife reserve, shielded from the rest of galactic society. Why would advanced beings do this? There are several reasons. They might value natural evolution. They may want to study how intelligence develops without outside influence. Artificial intervention would distort the results. They might also want to preserve diversity. If advanced civilizations shared all knowledge with young species too early, culture would homogenize. Every world would become the same. By isolating developing civilizations, the universe maintains a variety of perspectives and ways of life. There is also moral responsibility. An advanced species could see themselves as caretakers of the galaxy. They may have witnessed the destruction of life in the past due to war or exploitation. To avoid repeating that, they create protected zones. These zones prevent predatory civilizations from preying on weaker ones. Earth might be inside such a sanctuary, guarded without our knowledge. Imagine a park ranger watching over animals. The ranger does not speak to them. He does not tell them how to live. He only steps in when they face an external threat, like poachers or disease outbreaks. The animals never understand the ranger's presence. They think the forest is natural. Likewise, we think Earth's history is random. But what if some events were influenced to protect or guide us? Extinction-level asteroids may have been diverted. Key evolutionary paths may have been nudged. Ancient myths of gods descending from the sky could be distorted memories of rare interactions. A zoo without walls also implies boundaries we cannot cross. Every time humanity reaches a new level of exploration, something pushes back. When we try to leave Earth, we face immense technical challenges. Space is deadly. Radiation, vacuum, and distance are natural barriers. But some obstacles may not be natural. They could be design. There might be subtle rules built into physics that slow us down until we are ready. Faster than light travel might be restricted, not because it is impossible, but because it is locked. Let's imagine humanity finally reaches interstellar capability. We launch a ship toward another star.
Halfway there, we encounter something unexpected, a warning signal, a defensive barrier, or a boundary we cannot cross. We learn that travel beyond our region requires permission or proof of maturity. Our world is part of a larger structure with layers of access. We are in the beginner zone. The zoo is bigger than we thought, but it still has borders. The idea also explains UFO phenomena. If we are being watched, observers would come and go discreetly. They would not reveal themselves openly. They would avoid altering our society. Sightings of strange craft might be maintenance visits or monitoring missions. When they are seen, they leave quickly, like rangers avoiding interaction with wildlife. They do not land in city centers because that would disrupt the environment. The goal is stability, not contact. Cultural development could also be influenced. When a species is part of a managed system, it can be guided without knowing. Small events can steer history. A discovery made slightly earlier or later can change everything. Certain ideas may spread while others fade. Humanity believes in free will, but free will can exist within boundaries. A well-designed zoo does not force behavior, it shapes options. Some may ask, if Earth is in a zoo, why allow suffering? Why not prevent war or disease? In natural preserves, rangers do not stop every conflict. Predators hunt prey. Ecosystems balance through struggle. Intervention only occurs when external forces threaten the entire system. The same could be true for us. Aliens might avoid interfering with internal human affairs, believing that self-correction is part of growth. They only step in when events could wipe out the experiment entirely. Our survival through multiple global threats may not be pure chance. A zoo without walls requires long-term planning. The species managing it must be extremely advanced and patient. They think in millennia, not years. They might have governed the galaxy for millions of years. Their technology could make entire solar systems into controlled environments. We would not see them because they do not live within our visible layer. They operate in orbit, underground, or in higher dimensions. The silence of the universe feels lonely because we expect open communication. But silence is normal in a preserve. The observers do not announce themselves. They use subtle signals. They let us believe we are alone because that belief allows natural development. The galaxy might be full of civilizations, but the ones we are allowed to see are only a tiny fraction. The rest are behind the curtain, managing the park. One day, the walls may become visible, but until then, the zoo remains open, spacious, and quiet. We walk freely, unaware of the eyes watching from beyond the trees.
Most people assume that if aliens have ever contacted Earth, the event would be obvious. They imagine ships in the sky, global broadcasts, or government announcements. But contact does not have to be public. If intelligent life exists elsewhere and has chosen to interact with humans, it may have done so quietly. Selective disclosure suggests that only certain people have been contacted, individuals instead of societies, key figures instead of the general population. These interactions may be hidden not because of conspiracy, but because secrecy makes more sense than mass exposure. Why would aliens choose selective contact? One reason is risk management. Revealing themselves to all of humanity at once could cause chaos. Panic, religious upheaval, economic collapse, or political exploitation could spiral out of control, but reaching out to a single person or a small group allows controlled observation and influence. It mirrors how humans study animals. We do not engage with the whole herd. We tag individuals, track them, or occasionally interact with leaders. The herd never knows the full story. Advanced civilizations may take the same approach with us. Contacting individuals also allows testing. Aliens may choose different types of humans, scientists, spiritual leaders, strategists, or ordinary people to see how each responds. Each encounter provides psychological data. Do humans respond with fear or curiosity? Do they share the information or hide it? Do they try to use it for power? These reactions reveal the maturity of our species. Mass contact is irreversible. Selective contact is reversible. If something goes wrong, it can be denied, erased, or contained. History contains countless stories that fit this idea. Ancient myths often include accounts of gods descending from the sky to speak with chosen individuals. These messengers receive knowledge, laws, or visions. They return to their people and shape entire cultures. What if some of these stories were distorted memories of real interactions? The chosen individuals may not have understood who or what they meant. Over time, the encounters became legend. The message may have been lost, but the pattern remains. Contact through selected humans, not direct communication with all. Even in modern times, people report encounters, abductions, visions, or telepathic communication. Many of these claims are dismissed as hallucinations or attention-seeking. Some may be false, but the consistency of the pattern is worth noting. People from different cultures and time periods describe similar experiences. Bright lights, paralysis, missing time, strange beings, implanted ideas. If even a small fraction of these experiences are real, they could be part of a systematic contact program focused on individuals. Why keep it secret? Some humans who claim contact say they were told not to reveal everything. They describe warnings about global impact or instructions that humanity is not ready. Even if real, most of these messages are fragmented because selective disclosure is not meant to provide full knowledge. It is meant to deliver specific information, shape behavior, or prepare for future steps. The individual becomes a relay point, a node in a network that the wider population does not see. Governments may also play a role. If a small number of people are contacted, some of them might be officials, military personnel, or scientists. These individuals might report the encounters to authorities. Governments, wanting to avoid panic or maintain control, could classify the information. They do not need to know everything to suppress it. Uncertainty alone is enough to keep it hidden. If contact is ongoing, it could operate through deeply compartmentalized systems where even insiders only know fragments. Selective disclosure could also target people outside power structures. An alien civilization might deliberately avoid governments, believing that power corrupts. They may instead contact isolated or marginalized individuals who are more open-minded or spiritually aligned. These people may lack influence, so their stories are ignored or mocked. The message still spreads, but in subtle ways, through culture, symbolism, or shared intuition. In this way, contact becomes cultural rather than official. Another possibility is genetic or neurological compatibility. Aliens may not be able to communicate with everyone. They may require certain brain structures, emotional states, or DNA markers to establish contact. Only a small percentage of humans might have the right configuration. Contact would appear random,
but it would follow a biological logic. These individuals might be more sensitive to non-ordinary perception or altered states of consciousness. They could receive information through dreams, visions, or telepathic impressions. Society dismisses these experiences as imagination, but they may be carefully chosen communication channels. Let's imagine a scenario where an alien species wants to study human potential. They identify a few individuals with high intelligence or empathy. They approach them in dreams or through subtle guidance. They offer insight into science, ethics, or philosophy. Over time, these individuals produce breakthroughs in thought. History is full of sudden, unexplained genius, revolutionary ideas that seem to arrive out of nowhere. We call it inspiration. It could be selective contact. Selective disclosure could also take the form of influence rather than direct conversation. Aliens may seed ideas through mental nudges or symbolic events. They could subtly guide decisions without revealing themselves. A scientist may feel an unexplained intuition to pursue a certain path. A leader may suddenly understand the need for peace. A cultural movement may arise with no clear origin. We attribute these to human creativity, but they might be part of a larger design. Some people argue that if selective contact were real, we would have undeniable proof. But proof is not the goal. The goal is observation, influence, or preparation without destabilizing society. Proof would force contact into the public sphere. It would destroy the subtlety. Selective disclosure thrives in ambiguity. It works because it can be denied. It works because most people do not believe it. This perspective also explains the strange blend of visibility and invisibility in UFO phenomena. The sightings are real enough to generate attention, but vague enough to avoid certainty. It is almost as if someone wants the idea of contact to exist in the human mind, but not as fact, only as possibility. Possibility changes culture without breaking it. Possibility prepares us. Perhaps the silence we hear as we search the stars is not silence at all. It is the sound of a conversation happening quietly, spoken to a few, shaping the many.
Humans often assume that if intelligent life exists elsewhere, contact would be natural. We think advanced civilizations would reach out and include us in some grand galactic community. But this assumes we are ready. What if there is already a vast network of advanced civilizations in the universe, and we have not been invited? Not because they cannot find us, but because we are too primitive to join. A cosmic hierarchy may exist, an organized structure with rules, levels of access, and standards of behavior. In that system, civilizations must reach a certain stage of maturity before they are acknowledged. Until then, we remain quarantined at the bottom. Hierarchy exists everywhere in nature. Animals form dominant structures. Human societies create political classes. Even technology has layers of access: users, developers, system administrators. It would be naive to assume that galactic civilizations, with millions of years of experience, would operate without organization. If multiple advanced species exist, they likely formed alliances, treaties, and shared protocols. They may manage resources, maintain order, and prevent chaos. In that system, young civilizations like ours would not be allowed to roam freely. Access must be earned. What standards might they use to decide who joins? Technological advancement alone is not enough. We have rockets, but we also build nuclear weapons. We have global communication, but we spread misinformation. We can heal diseases, but we also destroy ecosystems. From a cosmic perspective,
humanity is unpredictable and unstable. The ability to control energy and matter does not prove wisdom, it only proves capability. A civilization that can travel the stars but cannot manage its own planet is dangerous. They might evaluate us on criteria like planetary stewardship, conflict resolution, cooperation, and sustainability. Can we maintain peace without collapsing? Can we allocate resources fairly? Can we think beyond our own species? By these measures, we are still young. We act like adolescents, intelligent but reckless. A cosmic hierarchy would not hand power to adolescents. It would protect the broader system from them. Think of Earth as a developing world in galactic terms. In human societies, developing nations must reach certain standards before joining major alliances. They need stable institutions, economic systems, and legal frameworks. They must prove they can operate responsibly. The galactic network might apply similar rules, only on a much larger scale. We cannot join until we demonstrate long-term stability. 1 century of technology is not enough. They may require thousands of years of peaceful development. Why not guide us? Why not teach us how to advance responsibly? Guidance can work, but forced advancement often fails. When powerful nations on Earth tried to impose systems on others, it led to collapse or resistance. Cultures develop at different rates. External influence can damage identity and cause dependency. Advanced civilizations may have tried to uplift species in the past, only to see it fail. Now they wait and watch. They allow civilizations to grow naturally. Those who reach maturity join the network. Those who self-destruct are left behind. This hierarchy does not need to be cruel. It could be protective. The galaxy may contain ancient powers or dangerous phenomena. If a young civilization explores too soon, it might trigger something it cannot handle. The hierarchy could act like a firewall, restricting access to certain regions or technologies until a species proves capable. That means we may be surrounded by invisible boundaries enforced by technology beyond our comprehension. Imagine humanity finally building a faster-than-light drive. We launch into the stars, confident and proud. Then we encounter a barrier, a field or signal that halts our progress. A message appears, access denied. We are told we lack clearance. We are not alone, but we are not equal. We exist in an outer layer, like a galactic probation zone. This scenario explains why no one has contacted us. They are waiting for us to pass the test. Signs of this hierarchy may already exist. We see strange objects in the sky that move with impossible precision. They do not land or communicate. They observe. These could be patrols enforcing the boundaries. When nuclear weapons appeared on Earth, UFO sightings near military sites increased. Some reports claim that nuclear missiles were disabled mysteriously. This could be a warning. The hierarchy monitors dangerous technology. They do not intervene unless we threaten more than ourselves. Their message may be simple. You can harm your own planet, but do not bring that danger into space. Even our search methods show our place in the hierarchy. We broadcast signals, but hear nothing. What if communication is encrypted at higher levels? The galactic network may use advanced forms of communication we cannot decode. To them, our radio waves are kindergarten scribbles. They might filter our signals as background noise. We think no one is speaking, but the conversation is happening on a bandwidth we do not understand. Hierarchies also create incentives. If we want to join, we have to change. The silence forces us to look inward. We cannot rely on outside help. We must fix our own problems. Only when we prove we can handle our own world will we be trusted with others. The hierarchy might not be hostile. It might be patient. History on Earth shows that contact between unequal civilizations often goes badly. The more advanced side dominates or destroys the other. even without intent. To avoid repeating this on an interstellar scale, the galactic network may hide its full presence. It reveals itself only to mature species. Immature ones remain in isolation until they grow or collapse. Humans believe we are ready for contact, but readiness is not self-declared. It is demonstrated. From the outside, a civilization obsessed with war, profit, and division does not look ready. We still struggle to unite even our own species. The galaxy may already know we exist. It just does not consider us eligible. If there is a cosmic hierarchy, humanity stands near the bottom, not as a failure, but as a beginner. The silence we hear is not rejection, it is structure. The network waits above us, vast and organized, and we do not yet have the keys to enter.
Humans tend to see history as a product of our own choices, discoveries, and struggles. We credit progress to curiosity, competition, and innovation. But what if not all of it came from us? What if some of humanity's most important steps were nudged forward by a hidden influence? Covert guidance proposes that a more advanced intelligence has subtly shaped our path without revealing itself. Instead of open contact, it works in the background, gently steering civilization towards certain outcomes while letting us believe we arrived there on our own. Why would an advanced species guide rather than control us? Control creates resistance. When people feel forced, they push back. Guidance done properly feels natural. It preserves free will while bending probability. A small change at the right moment can redirect the future. One idea introduced a century early can transform society. One prevented disaster can allow progress to continue. An advanced intelligence does not need to reveal itself to have enormous influence. It only needs to intervene with precision. Humans already do this to other species. Wildlife conservationists manage environments without letting the animals know. They reintroduce predators to control populations. They move herds away from danger. They plant food sources in strategic locations. The animals believe it is nature. We see the bigger picture and act quietly. If aliens view us the same way, covert guidance would be the most efficient approach. Let the system run on its own, but correct it when necessary. There are points in history that feel too convenient or strange to ignore. Certain breakthroughs appear before their time. Some individuals claim ideas arrived fully formed in moments of inspiration. Nikola Tesla described receiving visions of entire machines in his mind. Srinivasa Ramanujan produced complex mathematical formulas with no formal training, saying they came to him in dreams. We often call these people geniuses, but their knowledge sometimes seems disconnected from their experience. What if they were receivers rather than inventors? Guidance does not have to be direct conversation. It could be intuition, dreams, creativity, or sudden insight. Even cultural shifts can follow patterns that seem seeded. Ideas like human rights, democracy, and environmentalism emerged slowly across different societies, as if planted and allowed to grow. These ideas challenge primal instincts and promote long-term thinking. They push humanity toward global cooperation and empathy, traits necessary for a stable, advanced civilization. If aliens want us to become mature enough for contact, influencing values may be more important than influencing technology. Technology itself shows odd leaps. Humanity stayed in basic tool stages for thousands of years, then entered explosive advancement in just a few centuries. The agricultural revolution, the industrial revolution, and the digital revolution
each accelerated development. What triggered those shifts? Some were natural, but others seem abrupt. The sudden appearance of writing in multiple regions, the rapid spread of certain inventions, or the uncanny timing of scientific discoveries could suggest subtle nudges. Covert influence does not have to be mental. It could be physical. A small asteroid deflected before impact. A volcano's eruption delayed just enough to avoid wiping out a key population. A mutation guided toward higher intelligence. These events would look random or lucky, but randomness can be manipulated. A civilization millions of years ahead could move objects in space without being detected. They could alter environments on a planetary scale with minimal footprint. They might also guide by limiting us. If humans develop dangerous technologies too quickly, covert guidance may slow us down. Ideas could be suppressed. Key figures could lose influence. Attempts at breakthrough research could fail repeatedly for reasons that seem natural. This prevents us from destroying ourselves before we mature. Progress becomes carefully controlled pacing rather than reckless acceleration. Let's imagine a scenario. Thousands of years ago, early humans face extinction due to climate shifts. A small intervention, perhaps altering weather patterns or directing animal migrations, helps the right groups survive. Those groups develop language, cooperation, and innovation. Centuries later, a catastrophe threatens civilization. Again, a subtle nudge keeps progress on track. Every time humanity reaches a critical point, guidance adjusts the path. We do not notice because the changes are stitched into the fabric of history. Another form of guidance is symbolic. Advanced beings could use patterns, numbers, or astronomical alignments to embed messages in our cultures. Ancient monuments align with stars with extreme precision. Some structures encode mathematical constants. These patterns are too consistent to be coincidence, yet too widespread to be explained by simple observation. If someone was teaching early humans using architecture or mythology, the lessons might still shape us today. Religious and spiritual experiences also follow consistent themes across cultures. Higher beings watching from above, messengers delivering knowledge, judgment based on moral behavior, future transformation of humanity. These narratives could be based on actual experiences with a guiding intelligence. Over time, the details were mythologized, but the core message remained. Someone is watching, and our growth matters. Covert guidance may continue today. Some people claim guidance through intuition or synchronicity. Others believe global consciousness is shifting. Humanity is becoming more connected, more aware of planetary consequences, and more interested in long-term sustainability. This shift may not be purely human-driven. A small influence applied across generations can reshape civilization. The lack of open contact does not prove aliens are absent. It may prove they are careful. If we are being guided, the goal is not control. The goal is preparation. A species that wants us to reach a higher level cannot force us there. It can only create the conditions for growth and let us choose. That kind of guidance is hard to detect, but its effects may be visible across the rise of humanity. Our progress could be our own, and also the product of a quiet hand, adjusting the course just enough that we survive long enough to meet whoever waits at the end. Humanity's oldest stories describe powerful beings who came from the sky, performed impossible feats, and changed the course of civilization. We call them gods, spirits, angels, or demons. We treat these stories as myth,
symbolic tales created by early imagination. But what if some of these legends were not invented? What if they were distorted memories of contact with advanced non-human beings? Over time, the details blurred, the context was lost, and the encounters were rewritten as mythology. If so, ancient stories may hold fragments of real events, encoded in metaphor, because our ancestors lacked the language or technology to describe what they saw. When ancient people encountered something far beyond their understanding, they explained it using the concepts available to them. They did not know what a spacecraft or energy weapon was. They would describe a craft as a chariot of fire or a flying boat. They would call beings with glowing suits shining ones. They would interpret technology as magic. A laser becomes a divine beam. A medical procedure becomes healing by touch. The line between science and miracle disappears when the observer has no frame of reference. Across many cultures, similar patterns appear in mythology. Beings descend from the sky. They teach agriculture, writing, astronomy, or law. They interbreed with humans or create hybrid offspring. They warn of disasters or help survivors rebuild after floods. These stories repeat in different places that had no contact with each other. Ancient Sumerians spoke of the Anunnaki, gods who descended from the heavens and gave knowledge. In Greece, the Olympians lived in the sky and interacted directly with humans. In India, the Vedas describe flying machines called vimanas that could travel long distances and fire weapons. In the Bible, angels appear in pillars of light, and God descends in clouds and smoke. The consistency across cultures raises a question. Were these shared archetypes or shared experiences? Consider the story of the Great Flood. Versions of it exist in Mesopotamia, India, China, the Americas, and more. Why would so many cultures preserve a flood myth unless some large event occurred? The details often include a warning from a higher being, the chosen survivor, and instructions to preserve life. That sounds like intervention. Perhaps an advanced species witnessed an impending catastrophe and helped a small group survive. The story passed down over generations, losing accuracy but keeping the core elements: sky beings, warnings, survival, and gratitude. Some ancient texts go beyond metaphor. The Mahabharata describes battles with flying machines, explosions brighter than 1,000 suns, and weapons that left survivors with hair and nails falling out, symptoms similar to radiation exposure. The Book of Ezekiel includes a detailed description of a wheel within a wheel descending from the sky with fire and noise. These are not vague poetic phrases, they sound technical. If these accounts were written today, we would call them UFO reports. Architecture also supports the idea. Ancient sites like the pyramids of Egypt, Stonehenge, and the Nazca lines were built with precision that seems beyond the tools of the time. These structures align with stars and solstices in ways that suggest advanced astronomical knowledge. Did early humans develop this on their own, or were they taught? Many legends claim the builders were instructed by gods or sky beings. Rather than dismissing that as fantasy, we might see it as distorted history. The teachers were not magical, they were technological. Another clue lies in sudden leaps of progress. Civilizations often advanced rapidly without clear explanation. The Sumerians developed writing, law, and complex cities seemingly out of nowhere. The Egyptians mastered engineering and mathematics early on. The Mayans tracked celestial cycles with incredible accuracy. These breakthroughs may have been inspired or directly taught by visitors. The legends credit those who came from the stars. Modern scholars call it imagination.
But imagination rarely produces detailed technical systems. If advanced beings did visit, why did they stop? One answer is that they never stopped. They simply changed methods. In earlier times, humans were few and isolated. Direct contact was manageable. As populations grew and societies became more complex, open intervention became risky. Interacting with one tribe would create imbalance. Worship or resentment could lead to violence. The visitors might have shifted to covert observation, leaving behind only memories. Those memories became myths, but myths have staying power. They travel through time. Even when stripped of technology, the core message remains. Beings from the sky shaped our past. Perhaps they wanted us to remember, even if we could not fully understand. The idea of myth as memory also explains why humans across cultures instinctively look upward for meaning. We place our gods in the heavens. We associate the sky with creation, power, and judgment. This instinct may be rooted in something real. Our ancestors saw visitors come from above and never forgot the direction they came from. Even today, we search the stars, waiting for something we once knew. Skeptics argue that humans are pattern-seeking and imaginative, so mythology proves nothing. That is valid. We must be careful. Not every story is evidence of contact. But when myths from unrelated cultures describe the same themes, sky beings, flying craft, advanced knowledge, hybrid offspring, warnings of destruction, it deserves more than dismissal. It may reflect a shared memory of ancient contact, encoded in symbols because it was too overwhelming to describe literally. Imagine an early human encountering a being with technology far beyond anything on Earth. The being speaks, heals, flies, or vanishes. The human tells the story to others. Over generations, it becomes legend. Eventually, we call it mythology. But if that event truly happened, the myth is not fiction. It is history, told through the eyes of someone who lacked the words. Our job is to reinterpret the stories with modern understanding. Perhaps alien contact is not in our future. Perhaps it is in our past, hidden in the oldest stories we tell, waiting for us to read them as memories, not metaphors.
Humans often assume alien contact is a matter of technology. We think once we build faster ships or stronger telescopes, we will find them. But what if the barrier is not scientific? It is moral. What if Earth is part of a planetary test and our behavior is being evaluated? In this scenario, advanced civilizations may already know we exist. They could observe us from a distance, waiting to see whether we develop into a responsible species. Contact would not be automatic, it would be earned. Tests exist everywhere in nature. Before joining a group, you must prove maturity. Juveniles in animal packs learn discipline before becoming full members. Human societies use exams, training, and trust building. High-level access requires responsibility. It would make sense for a galactic civilization to use the same principle. If you let reckless species into advanced networks, you risk chaos. One unstable civilization with powerful technology could destabilize entire star systems. So the test is simple. Watch how a species behaves when it gains power. If it uses power wisely, it passes. If it destroys itself or harms others, it fails. Humanity is already in this phase. Over the last century, we reached key thresholds. We split the atom, discovered DNA, built global communication, and stepped into space. But with these breakthroughs came existential dangers. Nuclear weapons can wipe out civilization in minutes. Biotechnology can engineer pandemics. Artificial intelligence can escape control. Climate change threatens the biosphere. The test may be, can we gain power without self-destruction? Our actions are visible on a cosmic scale. We often think we are too small to be noticed, but our technology leaves clear signatures. Our radio transmissions leak into space. Our satellites orbit the planet. Our cities light up the night side of Earth. Our atmosphere contains pollutants and warming gases that would stand out to any civilization monitoring planets. Aliens could analyze our world and learn almost everything about us without setting foot here. This allows them to watch our choices. Do we prioritize cooperation or conflict? When faced with global crises, do we unite or fight? How do we treat our environment? Do we preserve life or consume it? Can we protect weaker populations or exploit them? These are not abstract ethical questions. They reveal whether we are ready to join others. Imagine an advanced civilization looking at Earth as a case study. They have seen other civilizations rise and fall. They know the signs of success and failure. They recognize patterns: war addiction, resource exhaustion, ideological extremism. They wait to see if we break the cycle or repeat it. If we break it, we prove we have learned. If we repeat it, we prove we are dangerous. This test might also be long-term. A civilization's maturity cannot be judged in a single year. It must be evaluated over centuries. That perspective explains why aliens do not intervene. If they step in too early, we might become dependent or resentful. Growth requires struggle. Progress must be internal, not imposed. Parents do not solve every problem for their children. They let them learn through experience. The same logic could apply on a galactic scale. Consider how Earth has faced opportunities for unity. Global issues like climate change, pandemics, and resource management require collaboration. But instead of working together, nations often compete, blame each other, or focus on profit. This reveals immaturity. Aliens watching would see a species with intelligence but lacking coordination. They would understand the danger of giving us advanced technology. We might weaponize it. The test could also involve how we treat ourselves. Do we value life? Do we protect our planet or strip it for resources? If we cannot care for our own world, why would we care for others? A civilization that destroys its home would likely destroy other planets as well. A galactic network would want to prevent this by filtering out destructive species. There may be specific milestones in the test. One might be ending large-scale war. Another might be establishing global governance or long-term sustainability. Another might be developing ethical use of technology. Passing each milestone could unlock subtle forms of contact. Maybe we have already received hints, mysterious signals, UFO sightings, sudden inspirations. These could be rewards or guidance encouraging us to advance further. Imagine a scenario where aliens monitor Earth with advanced probes. They observe everything: politics, culture, science. Conflict. When we act with wisdom, the probes record it. When we act with violence, they record that too. The data builds a profile of humanity's character. At some point, a decision will be made. Are we partners, threats, or failures? Some religions and myths reflect this idea. Many cultures believe humanity will one day be judged or ascend based on moral progress. Perhaps these stories are echoes of truth, distorted memories of past contact that hinted at a test. The gods were not divine, but advanced beings waiting for us to grow. If the planetary test is real, then contact is not about finding aliens.
It is about becoming a civilization they trust. Technology alone will not get us there. We must prove we can handle power without destroying ourselves or others. We must show empathy, foresight, and unity. Aliens may already be watching, not to invade or rescue, but to evaluate. The silence we hear might not be silence, it might be anticipation, waiting for our final answer to the only question that matters. Are we ready?